So we're going to talk about multiplication of polynomials in this video. And to get started, I want to talk about some special polynomials because these are terms I'm going to be using a lot. If we have a polynomial with one term, that is called a monomial. A polynomial with two terms is a binomial. A polynomial with three terms is a trinomial. Anything beyond that, we're just going to call polynomials. We're not going to have special names for anything beyond three terms. We're also going to be using a few laws, and that was supposed to be commutative. So the commutative law of multiplication and addition means we can switch the order of either. A times B is B times A plus B is B plus A. And with the distributive law, you can distribute a number over addition or subtraction. So A times B plus C in parentheses is going to be A plus B times A plus C. And these are all things that are going to pop up throughout this lecture. I want to talk about what it means to be an exponent as well. So if I'm multiplying a base by itself, I get that base squared. So in this case, x times x is x squared. If I have x times x times x, it's x cubed. And if I think about it, x times x by x times x times x, that's going to be x squared times x cubed. And if I go back and look, I have 1, 2, 3, 4, 5 x's. If I remove the parentheses, which actually the associative law says I can do, I should have wrote that down, but the associative law says we can remove parentheses or move them around with multiplication. We have x to the fifth. And this actually gives me a rule. And this is what we call one of the properties of exponents. We're going to go more into detail in these later, but for the sake of this lesson, we just need two. So if I have some base, so this is a product rule. If I'm multiplying two bases that are the same with different exponents, I add the exponents. And I don't know why my tablet's misbehaving, but it has been. And a quick example. A basic one, and then a slightly more complicated one. 2x multiplied by 3x squared. And again, I can remove my parentheses, comes dealing straight up multiplication here. And I can move the numbers next to each other with the commutative law. 2 times 3 is 6. X times x squared is going to be x to the first plus x squared, or 1 plus 2. And remember, if we don't see a number in front of a number or a variable, that's a coefficient of 1. And if I don't see a number as an exponent, I assume that exponent is 1, and that's always the case. I'm going to get 6x cubed. And if I have a slightly more complicated example with exponents, at least, again, I can ignore my parentheses and rearrange things. So I'm going to get x by I can multiply x by x squared. And I can multiply y by y cubed. I'm going to get x cubed y to the fourth. So if I look at something like x squared, and I'm going to cube x squared, that gives me x squared times x squared times x squared. And I can use my product rule to add my exponents, because this is just straight up multiplication going across. And if you recall, we defined multiplication to be repeated addition. I'm adding the same number over and over again. So that's going to be x to the 2 times 3, because I have 3 2s, and it gives me x to the 6th. So the product rule is if I have some base to a power raised to a power, so if I have a to the m raised to the nth power, I get to multiply my exponents. And a real quick example, I have 5xy squared. Well, that's the same thing as 5xy squared times 5xy squared, and do a little bit more work, but it's okay. Turns out that basically I'm multiplying all my exponents, or I'm squaring everything that's in there. So 5 squared is 25, x squared is x squared, y squared is y to the 4th. And these behave pretty naturally. And what we're doing basically here, in all these previous examples, we're basically multiplying monomial expressions. So with monomial expressions, when I'm multiplying together, I multiply my coefficients, I'm going to multiply all my bases together, and I'm going to take care of my exponents. Okay. So these examples, those examples illustrate how to multiply monomial expressions. So it means if I'm multiplying two algebraic expressions that only have one term, it's basically paying attention to coefficients and my exponents. Everything else from here on out is going to be using the distributive law and sometimes the properties that we just learned, because as we'll see, we'll be multiplying monomial expressions together, but things will be stitched together with addition, subtraction. So let's take a look. And this is really going to be distributive law. So we're going to multiply a monomial by a polynomial. I'm looking at 2 times 3x plus 1. This looks just like the distributive law. I'm going to say it's 2 times 3x plus 2 times 1. And if I multiply that out, I'm going to get 6x plus 2. And more often than not, folks are going to go from that original problem right to 6x plus 2. They're not going to write out that intermediate step of multiplying 2 by everything. You can if you want, but a lot of people won't do that. The distributive law extends over any number of terms. So in this case, I have 7 times this trinomial x squared minus 5x plus 2. I'm going to distribute the 7 across this entire trinomial. So I'm going to get a 7x squared minus 35x plus 14. And that happens pretty naturally. And we need to pay attention when we have things that are a little bit more complicated on the outside. If you recall, we can distribute a negative across, and that's going to change the sign of everything on the inside. But in this case, I'm distributing a negative 5x. So not only am I changing the sign of everything on the inside of the parentheses, I'm also multiplying everything by 5x. So negative 5x times 4 is a negative 20x. Negative 5x times a negative x. Hey, now that's two monomial expressions that we're multiplying together. Negative times a negative is a positive, and 5x squared. We can rewrite this 5x squared minus 20x, and more often than not, we're going to want to write our polynomials in descending order. I would say 90% of the time or more, it's more useful. And that's how I multiply a monomial times a monomial. With binomials, multiplying binomials together is a little bit more involved. I like to think about it as the distributive law. So let's take a look. Example, I have x plus 2 and x minus 5. And the way I like to think about this is I'm going to break up my first binomial, and I'm going to distribute each term over that second one. So I'm going to take the x from the first one, x minus 5, plus 2, x minus 5. And really what I'm doing is I'm taking, okay, so 2, or I'm sorry, the x right there, and then that 2. I'm distributing it. I'm taking the first binomial and distributing it piece by piece over that second binomial. Okay. So we can take care of this just like we did the monomial times binomials above. And we get a polynomial with 4 terms, but you might notice that I have a negative 5x and a positive 2x, and you might say, hey, can I combine my like terms? And absolutely we can and should. I'm going to get x squared minus 3x minus 10, and that's as far as I can go. And that is how we multiply binomials in a nutshell. Let's see one more. Let's look at 2x plus 1 and 2x minus 1. And when I multiply these together, I'm going to get a 2x times 2x minus 1 plus, there should have been a 2x plus 1 in there. And let's do the work. I'm going to get 4x squared minus 2x plus 2x minus 1. So make sure you're paying attention to your signs, and when I combine like terms, something happens. I get 4x squared minus 1. Sometimes you might see a binomial squared, and actually examples 2 and 3 are special products. We're going to learn about those in the next video in more detail. But for the sake of this, if I'm squaring something, that means I'm going to multiply it by itself. So my first step is to write that binomial squared as binomial times binomial. So x plus 2 times x plus 2. And that's going to be x times x plus 2. Continuing on with the process that we established. And if I distribute the x over the first binomial, I'm going to get x squared plus 2x. When I distribute the 2 over the same binomial, I'm going to get 2x plus 4. And when I combine my like terms, I'm going to get x squared plus 4x plus 4. So I'm going to talk about FOIL briefly. I don't like it that much because I think it's a shortcut that that leads to misunderstanding of how this stuff works. And that's first, outer, inner, last. So if I multiply my first terms together, and that's what this stands for, I have two first terms, x and x, and we get x squared. If I multiply my outer terms together, x times -2 is -2x. I have my inner terms, the 3 and the x are my inner terms. And then finally, my last terms are the constants here, 3 and -2. And that gives me something I can combine of x squared plus x minus 6. So this works great for multiplying binomials, but it doesn't do anything for trinomials. For example, if I'm looking at some more complicated expressions, if I want to multiply x minus 5 by 2x squared plus x plus 7, FOIL won't work anymore because, well, my first terms, my outer terms, my last terms are okay, but what about inner? The -5 gets paired up with what? I mean, I got all this stuff right here, so it's really hard to make that acronym work for this. If you want to use it for binomials, it's fine. But with this contraption here, I have a binomial times a trinomial. I actually need to go back to the way we defined multiplication of polynomials earlier. I need to split it up. And make sure you pay attention to your signs. So multiplying out my first binomial times trinomial, x 2x cubed plus x squared plus 7x, and then distributing -5 over the second, so -10x squared minus 5x minus 35. And make sure you're paying attention to your signs. That negative is going to affect the signs on everything in that second trinomial. Now is here where now is where I go and combine like terms. 2x cubed. It doesn't have any friends, so we're not going to combine it with anything, but x squared and -10x gives me a -9x squared. I said -10x, that was a -10x squared, I apologize. 7x and -5x is a +2x, and -35 is hanging out all by its lonesome, so that gets copied down. And so this gives me a 4-term polynomial times 2x cubed minus 9x squared plus 2x minus 35. And finally, we should look at an example where we have 3 polynomials getting multiplied together. And so let's consider x times x plus 1 times 2x minus 3. And there's really any combination of things that we can do. We can have 4 polynomials. They can have 1, 2, 3, 4, 5 terms. It really doesn't matter. Where the important thing is once you get past multiplying 2 polynomials together, it's really multiple steps, and you just make sure you're neat with your work and copying everything down that's needed. So what we're going to do is I'm going to take care of this first. And so if I distribute the x over the x plus 1, so I'm multiplying my first 2 polynomials together, and I get an x squared plus x, and I didn't do anything with a 2x minus 3. So I'm going to copy that down. And so whatever I get after my first multiplication, we're going to make sure we clean it up. If you have to combine like terms, do so. But this is already combined. I'm going to take my first binomial and multiply it by my second binomial. If you want to FOIL this out, you can, and you'll still get the right answer. And so when I multiply out the monomial times the respective binomials, I'm going to get this 4-term polynomial, and I'm going to notice that the middle terms add up again. Doesn't always happen, but more often than not, it does. And my final answer is going to be a trinomial that's 2x cubed minus x squared minus 3x. And that is an overview on how you multiply polynomial expressions. I'll see you in the next video.